from data stream. So what is a median? Median is if it's an odd number, then this is the middle number of it, or if it's an even number, um, then that's the number between two of this right here. So let's say if there were 5 right here, then we would have added 3 and 4 and divided by 2. That's our median. And in this problem, it's asking us to implement the data structure that adds a number and finds its median. So one of the ways to solve finding the median, we can do it with 2 heaps. So one heap will be a max heap, which will be holding all those values which are smaller values, and then min heap, which will be holding all those larger values. So the top of the min heap is the smaller number. The top of the max heap is the larger number. So by combining them together, we can find its median. So let's implement that. Boom, priority queue, integer max heap for larger numbers. So max heap is for smaller numbers because the top is the larger one. And priority queue, integer min heap. Perfect. So in here, let's define them. Max heap equals to new priority queue, and we need to our expression here, and for min heap, so min by default it's just min heap, so we don't need to express this. So for adding number, what we can do is like we can choose either of them, min heap or max heap, to add it. So let's start with min heap. So we can add to either of them. So because we need to start from somewhere. So we can say if we'll add it to min heap, then min heap is empty. So if it's not empty, then look at the or, like if it's okay, if it's empty, or like if it's empty, then we are adding it, or if it could it might not be empty, so then we will pick the value and see if it is, so the top of this min heap will have the minimum number because we are trying to add the larger number. So if it is, this given num is larger than the top of it, then add to here because we are collecting all those larger numbers in our min heap. And so min heap add this number, else we'll just add to max heap. Perfect. So there could be cases where this might be out of balance, so we need to balance them, and the way we are going to do it, we will check the sizes. So if min heap size is larger than max heap size, so we will add, because to our max heap, min heap remove else if else if min heap size is smaller than max heap size, then add to min heap, add max heap, remove. Since we started adding 1 into our min heap, then we need to take into that consideration. So min heap size, if it is bigger than this one, then max heap, because the way we're going to calculate it will also have this had already 1 in here, so we need to add 1 to here. So that's how we know that min heap size is bigger than the max heap, because in min heap we already accounted 1, because we are adding when it's empty, and that time when we are comparing it, if it's larger, then we need to add 1 to account that, and then we'll be adding it. Else if min heap could be smaller than our max heap, then we're just adding it to max heap. So we need to find its median now. The way we're going to find the median is we need to make sure if it's odd or even number. So let's int heap size. So just say min heap size plus max heap size, and if this is equals to 0, that means it's median. It's even number, so return min heap peak plus max heap peak. So the two numbers divided by 2, and this is a double number, so by double. Otherwise, just return min heap peak. Perfect. Let's run our code. Let's submit it. That's about it.